I'm Narmada of Tendi. Have you ever drawn rangoli or made mehendi design? We have all built pyramids from cards in our childhood. We have all been astounded by how the hanging bridges are standing over the flooding waters. Do you know what is common in all of them? Calculation. The first thing that comes to your mind when thinking about calculation is mathematics. Can you guess why we are talking about all these things today? Because today, December 22nd, is National Mathematics Day. It was on this day in 1887 the Indian mathematical genius Srinivasa Ramanujan was born at Erode, Tamil Nadu. To recognize and celebrate the works of Srinivasa Ramanujan, our former Prime Minister Manmohan Singh declared his birthday as National Mathematics Day. Srinivasa Ramanujan, who is also known as the man who knew infinity, did not receive any formal education in mathematics, but made important contributions to the field of mathematics. The mathematician Srinivasa Ramanujan's journey to being a genius began when he wrote a letter to Trinity College where he had mentioned about 120 mathematical theorems. He joined Trinity College a few months before the outbreak of World War I. In 1960, he was awarded the Bachelor of Science degree. The next year, he was elected in London Mathematical Society. In 1918, he was elected as a Fellow in Royal Society for his research in elliptic functions and theory of numbers. One of Ramanujan's findings is the Hardy-Ramanujan number. 1729, the Hardy-Ramanujan number is the smallest number which can be represented as the sum of cubes of two different numbers in two different ways. 1729 is the sum of cubes of 10 and 9. 1729 is also the sum of cubes of 12 and 1. Though Ramanujan number is not his greatest discoveries, it certainly is one of his fascinating discoveries and the easiest to remember among his discoveries. Srinivasa Ramanujan is a man whose contributions to the field of mathematics are unmatched. Most noteworthy, he made our country proud at a time when India was still under British rule. How could we make him proud of? Mathematics is all around us. Enjoy mathematics not only by studying but also understanding the concepts. You can be a doctor, an engineer, an auditor, etc. Whatever it is, what is common is calculation, that is mathematics. I take this opportunity to thank our beloved Secretary Madam, Principal Madam, Vice Principals and teachers for giving me this opportunity to speak about the greatness of Indian mathematical genius Srinivasa Ramanujan. Thank you.
Namaste to all. I am Srinivasa of Tensi. Today I am here to speak about the works done by Srinivasa Ramanujan on exponents.
What are exponents? An exponent is a quantity representing the powers. The exponent is usually written at the top of the right corner of the base and smaller in size.
Srinivasa Ramanujan, the great Indian mathematician, has created so many beautiful equations using exponents during his childhood. Here is an interesting exponential equation from his most popular book, Notebooks. 2 square into 6 power 6 into 1 power 1 into 1 power 1 is equal to 3 cube into 3 cube into 4 power 4. The base and power are equal in both the sides. Moreover, the sum of the base and power in both the sides are equal. That is, 2 plus 6 plus 1 plus 1 is equal to 3 plus 3 plus 4 is equal to 10. Hence, he solved it by using the laws of exponents. Ramanujan is also famous for his Ramanujan-Nagal equation in the number theory. It was named after Ramanujan because he was the only person to solve the 5 integer solutions after the mathematician Nagal.
Not only this, he is also famous for his Ramanujan conjecture, Ramanujan prime, Ramanujan constant, Ramanujan Sato series, and many more.
Ramanujan is an absolute treasure to our country. It is an honor to remember the person who knew the infinity. Thank you.
Namaste to everyone. Hi, I'm PK Nisha of 8th standard from Sita Devi Garudia Hindu Vidyalaya School.
Hi, this is Rekashri from 8th standard from Sita Devi Garudia Hindu Vidyalaya.
We are here to show you an interesting thing on maths, which is Ramanujan's magic square. Yes, from the name itself, we can get it that it was invented by Ramanujan. Rekashri, can you please tell about Ramanujan?
Sure, Srinivasa Ramanujan was an Indian mathematician who lived during British rule in India. He developed his own mathematical skills in isolation. Initially, with IA's help, Ramanujan had his work published in Journal of Indian Mathematical Society.
Yes, he's a great mathematician.
Nisha, I'm very curious to know about magic square. Nisha, can you please explain me about the magic square or the method of Ramanujan?
Sure. Magic square is nothing but the arrangement of equal number of rows or columns, which when we add diagonal wise or row wise or column wise or only the four corner or only the center, we get the same total. For this magic square, we'll have to follow the procedure called null matrix. Ekashti, do you know what is null matrix?
Yes, Nisha. Null matrix is the formula used to calculate the columns and rows which we get the same total.
Now let's see with an example. 24 will be our date, 11 will be our month, and this 1997 is a year. Now we are going to split this 1997 into two parts. 19 is our first part and 97 is our second part. Year plus 1, which is second part. 97 plus 1, 98. Half of the year. 19 minus 1 is 18. Month. 11 minus 3 is 8. And date. 24 plus 3 is 27. And goes on. Now let's take this date of birth as an example. We are going to substitute this date of birth by null matrix format. Let's see. Date plus month,
Half of the year and the year. So here we have y plus 1 and y is 97. So 97 plus 1 is 98. So half of the year is 19. So 19 minus 1 is 18. Our month will be the 11. So 11 minus 3 will be 8. Date is 24. So 24 plus 3 is 27. Month is 11. So 11 minus 2 is 9. Date is 24. So 24 plus 2 is 26. Year is 97. So 97 plus 2 is 99. So half of the year is 19. So 19 minus 2 is 17. So half of the year is 19. So 19 plus 1 is 20. So our year will be 97. So 97 minus 1 is 96. Date is 24. So 24 plus 1 is 25. And we have month as 11. So 11 minus 1 is 10. When you add all the numbers in the first row, we get 151. This is same for second row, third row and fourth row. When we add all the numbers in the first column, we get 151. This is same for second column, third column and fourth column. When we add all the numbers in the diagonal, we get 151. And when we add all the numbers in the center, we get 151. This is called as Ramanujan's birth date magic square. Is it interesting, Nisha?
Yes, it is very interesting, Rekashti. I liked it. Hope you all liked it.
Yes, check this pattern using your date of birth. Thank you.
Mathematics or tips which will help you to master them. Memorizing tables is very important. After all, they are the building blocks of maths. With your multiplication skills and tables mastered, you can almost solve every problem quickly. Let's start by learning a few multiplication tips and tricks which will help you to master the tables in a quick and easy way. Let's start with the 2 times table. As for the 2 times table, we are going to start writing the numbers from 2 to 8 with a 0 at the end. So 2, 4, 6, 8 and 0. Then again 2, 4, 6, 8 and 0. As for the tens digit, we will write the numbers 0, 0, 0, 0 in the first 4 boxes and 1 in the last box. And again start with 1 and for the first 4 boxes and 2 in the last box. And this is our 2 times. As for the 3 times table, we are going to start drawing a tic-tac-toe grid of 3 into 3 with 3 rows and 3 columns. We are going to start writing the numbers from the bottom left box and going forwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And as for the tens digit, we will write 0 in the first row, 1 in the middle row, and 3 in the last row respectively. So 0 on the outside, 0 on the inside, 1, 2, and 3. And this is our trick for the 3 times table, starting from 3 times 1 to 3 times 10. Next, as for the 4 times table, we are going to draw a M, or rather an upside down W. We are going to write the numbers 2, 4, 6, 8 and 0. Then again 2, 4, 6, 8 and 0. This is our ones digit. As for the tens digit, we will write the numbers 0 in the top for the top 2 numbers, 0 and 0, 1, 1 and 2 in the last 3 numbers. And for the second M, we will write 1, 2, 3, 3, 4, and this is our trick for the 4 times table, starting from 4 times 1 to 4 times 10. Next, this is our trick for the 5 times table. Our 5 times table consists of a 5 into 2 grid of 2 rows and 5 columns. For the ones digit, the numbers follow a pattern of zeros and 5, starting from 5 and ending with zeros. So 5, 0, 5, 0, 5, 0 and so 2 grid of 2 rows and 5 columns. For the ones digit, the numbers follow a pattern of zeros and 5, starting from 5 and ending with zeros. So 5, 0, 5, 0, 5, 0 and so on till you end up with a single 0. This is our ones digit. For the tens digit, we are going to write the number for in a particular pattern. The pattern follows as 0, 1, 1, 2, 2, 3, 3, 4, 4 and 5. As you may have noticed, we are going to write a number twice. So 0, 1, 1, 2, 2, 3, 3, 4, 4 and 5. And this is our trick for the 5 times table. As for the 6 times table, we are going to need to draw a 2 tic-tac-toe grid. This is follows a same trick as the 3 times table. We are going to write starting from leftmost bottom box and go forwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and a 0 outside. Then same. Now this is actually 3 times 1 so 3 times 20. See, for the tens digit we will write 0 in the first row, 1s in the second row, 2s in the third row and a 3 outside. For the second box, 3s in the top row, 4s in the middle row and 5s in the last and 6 outside. And this is our 6 times tables trick. Sounds simple, doesn't it? Now we are going to draw a diamond. The number which the diamond touches are our 6 times table. We are circle those and connect the 30. And again draw another diamond, circle the numbers it touches and connect it with the 60. And this is our trick for the 6 times table. The numbers which are circled are our 6 times table. As for the 7 times table, we are going to need a tic-tac-toe grid of 3 into 3. We will start writing the numbers from the top right corner and go downwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and a 0 outside. This is our ones digit. We will write the numbers 0, 1, 2, then again start with 2, 3, 4, then again start with 4, 5, 6 and 7. This is our trick for the 7 times table. As for the 8 times table, we will write the tens digit first and then the ones digit. The tens digit starts from 0 to 4. So 0, 1, 2, 3 and 4. Remember to start 4 again. 4, 5, 6, 7 and going forward. So 0, 2, 4, 6, 8. Then again we have to write 0 to 8. So 0, 2, 4, 6 and 8. And this is our trick 8 times table. For the 9 times table, we will follow a simple trick. We will write the numbers from 0 to 9 for the tens digit. So 0, 1, to 9, and for the ones digit we will write the numbers from 0 to 9 again, but this time starting from the bottom and going forwards like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and that's it. This is our 9 times table. As for the 10 times table, the trick is very simple. You just write 10 zeros for the ones digit. So 0, 0, 0, 0, 0 and so on. For the ones digit, we will write the numbers from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And this is our trick for the 10 times table. As for the tricks for the 11 times table, the trick is quite simple. See, the 11 times 1 is 11. If we add 11 plus that, we will get 11 times 2, which is 22. So 22 plus 11 gives 33, and 33 plus 11 gives 44, 44 plus 11 gives 55. This is a first trick. The second trick is also that. As you can see here, the multiplicand is 6. So we have to write 6 twice. We have to write 6 twice. Remember that. Okay. So we are writing 66, 77, 88, 99. As for the 11 times 10, we just write 11 with a 0. And this is our 11 times 10. As for the 12 times table, the trick is quite simple. We just write the numbers at 2, 4, 6, 8, 0. Then again 2, 4, 6, 8 and 0. This is one digit. For the 10th digit, we need to write the numbers from 1 to 12. Sounds simple, doesn't it? But it isn't. We have to skip a particular few numbers. See? 1, 2, 3, 4. Skip 5 and 6, 7, 8 and skip 11 and 12. I repeat, we have to skip the number 5 and 11 so that we may get our 12 times table. As for our trick on the 13 times table, it's quite simple. We just have to draw a tic-tac-toe grid of 3 into 3 and start writing the numbers from the bottom left box and moving upwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9. For the ones digit, we will start writing from the top left box and going like this. So 1, don't forget to write the 0 outside. So 1, 2, 3, skip 4, 5, 6, 7, skip 8, 9, 10, 11 and skip 12 and write 13. As you may notice, these are the multiplicative numbers for 4 times 1, 4 times 2 and 4 times 3. This means we have to skip the 4 times table here. The numbers which are from the 4 times table. See, that's why we skipped 4 as it is 4 times 1, 4 8 as it's 4 times 2 and 12 as it's 4 times 3. Remember, I repeat, skip 4, 8 and 12. Next, for the 14 times table, we will draw a M or rather an upside down W. The ones digit trick follows same as the 4 times table. We will write the numbers 2, 4, 6, 8 and 0. Then again 2, 4, 6, 8 and 0. For the tens digit, we will write the numbers 1, 2, 3, skip it, 4, 5, 6, skip it, 7, 8, 9, skip 10, 11, 12, 13, skip it, and 14. The numbers which we have to skip for the 14 times table are 3, 6, 10, 13. I repeat, 3, 6, 10 and 13 are the numbers which needed to be skipped for the 14 times table. Next, as for the 15 times table, the ones digit follows the pattern just like it did in the 5 times table. We are going to need to follow a pattern of 5s and 0s. So 5, 0, 5, 0 and so on till you end up with a 0. And for the ones tens digit, it follows a pattern of 2 consecutive odd numbers, then 2 consecutive next even numbers and 2 consecutive next odd numbers. I will explain here. 1, 1, 1 and 3 are the first 2 consecutive odd numbers. Then 4 and 6. The very reason we are choosing 4 and 6 because we need to choose the even number which is after the odd number which is at last. So 3 is the odd number which is at last and 4 is the even number which is after 3 and the consecutive next even number after 4 is 6. It might be sound a bit complicated but it's really simple. Next, as you may have guessed it, we need to write 7, 9, then 10 and 12, then at last 13 and 15. And this is our trick for the 15 times table.
You had an interesting session. I really hope it helps you. I am very much grateful to our respected President G, our beloved Secretary Ma'am, Principal, Vice Principals, teachers, and to everyone who are watching this. Thank you all for this wonderful opportunity.